Greetings everyone and greetings Sir Patrick. I am Radiri Maloles and today's presentation we are going to present the showcase of our solution to the final object-oriented programming project, the QuickMart point of sale system. Before we dive into the architecture, I'd like to introduce the developers who made this possible. Alongside myself, our team consists of Mark Andrew ABAIRO, Anthony AMBAT, Paul Vincent Bernal, VJ Bacilonia, Danilo CABUNAS, April Joy FRANCO, Cassandra Nicole SANTE, and Christian Carl SILAN. We divided the workload to ensure every requirement of the problem statement was met. Our task was to design a fully functional point-of-sale system for a small retail store called QuickMart. We built this entirely in Java Swing as a desktop application. The system was successfully handles three product categories, manages real-time cart operations, computes 12% VAT, and generates itemized checkout receipts. To make the system scalable and organized, we strictly applied the four pillars of OOP. First is the encapsulation. All product fields like ID, name, price, and stock are kept strictly private and only accessed via public getters and setters to protect our data. Second is the abstraction. We created an abstract product class that cannot be instantiated directly and serving as a blueprint. Third is the inheritance. We then created a subclasses for beverage, snack, and household item that extend this base product class automatically inheriting those shared fields. And finally, the polymorphism. We override the apply discount method directly for each classes. For example, beverage get a 5% discount, snacks get 3%, and household items get 0 all handled dynamically. We didn't just stop at basic OOP, we implemented three design patterns to handle the system logic. We used the single turn pattern for the cart. This ensures exactly one cart exists per POS session, preventing duplicate totals. We use the factory pattern via product factory.java instead of messy constructor all over our GUI code. The factory dynamically builds the correct object type when requested. Most importantly, we use the observer pattern, so the card acts as the subject and whenever an item is added or removed, it automatically notifies GUI observers to instantly update table and the totals, so no manual refresh buttons are needed. So to make the QuickMart truly functional, we integrated several bonus features. We implemented a hard-coded secure login system using admin credentials to prevent unauthorized access. We also added live inventory tracking where stock decreases when added to the cart and restores if the cart is cleared. Lastly, we focus heavily on creative UI with custom paint cards and image-ready product files. So, how does it all come together? The flow is intuitive, so the cashier logs in and browses product display in a responsive wrap layout with. So when they select an item, adjusts the quantity. They click add to cart. So then thanks to our observer pattern, so the system automatically updates instantly. From there, clicking checkout computes the final totals with VAT, generates the receipts, and releases the system for the next customer. So we dedicated 20% of our effort specifically to the GUI design. So you'll notice category filters using pill-shaped toggles, alternating raw colors in the card table, and dark live totals panels to highlight the final price. We even included a real-time clock in the header and floating toast notification for success or error alerts. So to reflect for our development journey, choosing these specific design patterns made our system highly scalable. So if QuickMart wants to add a new category like electronics, we just add a new subclass and update the factory so the rest of the system would work. So for the furthermore explanation of the code, so please ready for the next reporter. So as they explain the flow of the system properly. So thank you for your listening.
Greetings everyone, I'm Christian Garcilan and I'm going to explain the main Java program, household item program, and UI walkthrough. So let's start with the main Java program. On our main Java program, we have this block of code, the try catch. So this code acts as a styling foundation for the entire project. by setting a consistent cross-platform so look and feel for the interface. It ensures that the custom color and rounded design on your Quick Mart so look exactly same as on every computer, regardless of the operating system. So next line of code. So this code ensures that the application launches on the event dispatch thread. So which is the industry standard for keeping Java Swing interface smooth and responsive. So by starting with a login frame, it established the secure gatekeeper that requires authentication before anyone can access the main point of sale system. So that's our main Java program. Let's proceed to the household item program. So first we have this block of code. So this code defines the household item subclass, which use interface to gain all the core features of the product while adding specific attributes like branding and usage. So it demonstrates the abstraction by providing specialized data for non-food items, ensuring the point of sales catalog can handle diverse categories. So this next block of code, this constructor initialize the specific or specialized household item by using the super keyword to pass shared data like a price and stock to parent product class. So it ensures that each household product is created with a unique brand usage and image path which allow UI to display specific details for every item in the catalog. So next we have this block of code. So that block of code demonstrate encapsulation by providing control public access to the private brand and usage field. So this ensure the UI can retrieve a specific this product detail without allowing external classes to modify the data directly. So next we have override. This block of code demonstrate the polymorphism and abstraction by providing specific element implementation for the abstract method this defined in the parent class. So it allows the GUI to dynamically identify the display, the category of item, the household without needing to know the specific subclass type. So next again, override. So this code demonstrate again polymorphism. So by overriding the apply discount method to define a specific business logic for this category. So it ensures that while other products might have price reduction, household item return the original price without any discount applied. So that's our code. So let's proceed to the UI walkthrough. Let's run our program. So it shows a login page. So on our login page, you need to type the username. So admin and password 1234. So login, click login, and just wait a few moments to show the our dashboard. So let's maximize the screen. First, on our dashboard, we have a quick mart point of sales. Our header contains cashier admin. So we have items and cart number. This will increase if we add some product on our cart. So let's try this later. So we have the real time so and logout button. So next we have filtering for our product. So this is all product. So next we have a beverage. So next snacks and household. So we select all so we can add some product. So let's try to add to cart using this button, and we can set the quantity. So let's start with a Coca-Cola, for example. I have 3 Coca-Cola, so add to cart. You can see items in cart increase to 3. So let's add some more. So mineral 3, add to cart. So it will show on the screen. Some chips, uh, some toothpaste, safeguard, chocolate, and so on items cart we have 16 products. So 3 Coca-Cola, 3 mineral, 3 chips, 3 Colgate, 3 Safeguard, and Cloud9 2. So on the screen, you can see the image of the product name or the product, the type of the product, beverage, snack, household snack, and the price of the product. So one Coca-Cola is 75, mineral 25, 28, Colgate 80, Safeguard 45, and the Cloud9 is 20. So quantity, we have a quantity. So 3 for the Coca-Cola, uh, 3 times 75 equals 225. So that's the subtotal of our product. So next, you can see the value added tax or the tax and the subtotal. So 754 plus 9048. So we have a total of 844.48. So for example, we remove some item. So uh, we need to select the item that we want to remove. So for example, this toothpaste. So remove, and you can see it will remove on the screen. So on the preview, you can see like preview of the receipt. So like this. So click OK. On the preview, you can see the transaction ID, cashier admin. So the date, Sunday, April 19, 12:46. Item, the quantity and the amount, Coca-Cola, Mineral Nova, Safeguard Cloud9, subtotal or 514, and the value added tax, so 12%, 61.80 pesos. So the total of 575.68 pesos. So click OK. So if you click this clear card, we have you can see pop up a clear item from cart. So if you click yes, you can clear all the product that you add to cart or in the cart. So let's try to check out Coca-Cola, quantity of 2, chips, quantity of 1, some soap, quantity of 1. So let's try to check out this. You can see the receipt. So transaction ID, cashier, admin, date, item, quantity, amount. So subtotal, the value added tax, 12%, the total. And yeah, that's our receipt. So let's click the close. And that's all for our quick mart point of sale system. So we have a logout button. So if you click this, are you sure you want to log out? Yes. And you can back to the login page. That's all. Thank you.
Greetings everyone. In this section, we will be discussing the class relationships and multiplicity of our point of sale system. Our class diagram consists of 10 classes, each playing a specific role in the overall design of the program. Let us go through each relationship one by one. So the first relationship we have is inheritance, also known as the is a relationship. At the top of our diagram, we have the abstract class called product. Si- Since it is a abstract, it cannot be created on its own. It only exists to be extended by other classes. The three classes that extend product are beverage, snack, and household item. All three of them automatically inherited the shared attributes of product, which are product ID, name, price, category, snack, eh, stock, and image path, as well as the method get product ID, get name, get price, decrease stock, and increase stock. Each subclass then adds its own unique attributes. For example, beverage adds its cold and volume MI. Snack adds weight grams and is vegan, and household item adds brand and usage. All three is also override the get product type. Snack adds weight grams and is vegan, and household item adds brand and usage. All three is also override the get product type and apply discount methods to fit their specific category. The multiplicity here is one-to-one, meaning every single beverage, snack, or household item objects that exist in the system is exactly one product. The second relationship involves the product factory class, which uses the factory design pattern. The purpose of this class is to handle the creation of the product objects so that the rest of the system does not need to worry about how products are instantiated. It has only two methods: create product, which accepts parameters like type, ID, name, price, stock, and image path to build the appropriate product object, and create sample inventory, which returns a ready-made list of products. This is dependency relationship. Factory does not permanently store products, it simply produces them on demand. The multiplicity is one product factory to zero or more products, since one factory can generate any number of product instances. So the third relationship is simple association between cart item and product. A cart item represents one line item inside the shopping cart. It wraps a single product object and pairs it with a quantity. This is labeled as a reference association in the diagram, meaning cart item holds a direct reference to its product. So the multiplicity is one-to-one. Each cart item is linked to exactly one product at a time. The methods get subtotal and get discount subtotal. Both rely on this product reference to compute the correct price for that item. So next relationship is the composition, also called as the has a relationship between cart and cart item. This is a strong ownership relationship. Cart items are created, managed, and exist entirely within the cart. They have no meaning outside of it. The cart uses add item and remove item to control which cart items are inside it, and holds them all in the cart list item. The multiplicity is one cart to zero or more cart items, meaning the cart can be empty or hold as many items as the customer adds. The fifth relationship is the realization, which implements the observer design pattern. Cart observer is an interface that declares one method on cart update, which accepts a cart object. Pause frame implements the interface, which means pause frame is required to provide its own concrete version of on-cart update. So this method is called automatically whenever the cart contents is changed, allowing the pause frame to refresh its display without the cart needing to know anything about the UI. The multiplicity is bound one. One cross frame realize the one cart observer interface. The sixth relationship is an aggregation between cart and cart observer. The cart maintains a list of observers and notifies them whenever something changes using the add observer method to register them. This is an aggregation and not composition because the observer objects like pause frame exist independently and are not owned or destroyed by the cart. The multiplicity is 1 to 0 or more card observers, since the card can notify any number or of registered observer. So next one is this relationship. The seventh relationship is also an aggregation. So this time between pause frame and cart labeled as observes in the diagram. Pause frames holds a reference to the cart object and uses it to display items, compute totals, and process the checkout through methods like update cart UI and checkout. The multiplicity is one-to-one. One pause frame session operates on exactly one cart at a time. It is worth nothing that cart is implemented as a singleton, meaning only one instance of cart exists throughout the entire runtime of the program. The eighth relationship is another aggregation between frame and product. Frame holds an inventory attribute, which is a list of product objects loaded into the system. This list is displayed to the cashier through the setup products grid method so they can select items to add to the cart. The products are created externally by product factory and simply referenced by frame. They are not owned by it. The multiplicity is one frame to zero or more products. The ninth and final class is frame, which stands on its own in the diagram with no drawn association to the other class. Frame is the entire entry point of the entire application. With it contains the login fields for the username and password and uses the attempt login method to validate the cashier's credential before granting access to the POS system. It also contains the main method, which is very first method the runs that runs when the program starts. Once login is successful, it launches the fast frame for the cashier to begin operation. To summarize, our system is built around 10 classes with 8 distinct relationships, including inheritance, factory pattern, association, composition, realization, and aggregation. So the abstract product class serves as the foundation of the inventory. The cart is the operational core implemented as a singleton. The observer pattern connects the cart to the cost frame so the UI stays updated in real time. The factory pattern through product factory keeps product creation clean and organized, and login frame secures the system by controlling access before any operation begin. This that concludes our discussion on the class relationship and multiplicity. Thank you. Um, the pro- I am April Jess Franco from the CSA. So thank you for listening. That's all.
Tingal greetings, I'm Cassandra SANTE, and today I will explain the complete structural architecture and integrated object-oriented flow of our QuickMart point-of-sale system. This platform is designed to handle retail inventory and transactions through a modular framework that leverages advanced design patterns. Starting at the top center, we observe the product class, which serves as our root abstract superclass. In our code, the class utilizes private visibility for its field to ensure strict encapsulation. So while defining abstract methods like apply discount and get product type, this establishes a mandatory blueprint or abstraction that forces all specialized products to implement their own pricing logic. So connected to this parent are the specialized subclasses linked via an inheritance relationship. So this represents a formal is-a relationship where each child inherits the base identity of a product while implementing polymorphism. For instance, beverage class applies about discount, while the snack class uses its own specific discount rate. So to handle dynamic creation of these objects, we implemented the factory design pattern via the product factory class. It is linked via a dependency relationship as it is responsible for instantiating the correct concrete product type based on its inventory categories, effectively separating the construction logic of the main application flow. So this core orchestration of the transaction happens here in the card class, which implements a singleton pattern to ensure only one active session exists throughout the application. This field diamond represents composition that the strongest has a relationship because the life cycle of card items is strictly lied to the card. They are managed automatically whenever the transaction is processed or cleared. So a vital feature of our system is real-time UI synchronization via the observer design pattern. The card observer interface defines the update contract, which are pause frame class realizes. This realization ensures that whenever the card's state changes, the GUI is automatically notified to refresh the sales dashboard. So finally, the system execution flow begins with the main class, which triggers the login frame gatekeeper. Upon successful authentication, the login frame establishes a dependency on the pause frame to launch the secure sales interface. By organizing our platform into these distinct class in compartments and maintaining standardized relationships, we have developed a robust and academically sound architecture for retail management. Thank you for your time and attention.
So, greetings po sir. In this video, I'll be explaining the POS frame.java from the line 387 and line 324. So, this POS frame.java is the code for our finals project. So, allow me to explain the code. So from the 387, so this we implement a cart the table. So we this is for the UI of our system. So in this line of code we have G panel for the make total. So in this part, so it is the receipt of our system. So all the subtotal and the VAT and the total amount is displayed using this function. So let's proceed. So this we have private G panel make status bar. So G panel bar, we instantiate the G panel. So it will display a label status, system already, and select a product to begin. So for the handle add, we have if statement for if the selected product is equal to null. So it will toss a message for the select product first. So we have also an if statement for the selected product that gets stuck. So it will toss the not enough stock available. So if it passed the validation, so it will display the added to cart. So we have also a function for handle remove. So this the users allowed to remove their selected product. So this we implement a variable row for the with the integer data types with the cart table. So it will get the selected row. So we call this function. So if we have if statement here, if row is less than to 0, so it will toss select a cart item to remove. So the users is need to select an item to remove. So we have also a function for the private void handle clear. So we have also an if statement for this. So if cart that is empty, so it will toss the cart is already empty. So if the G option pane is show confirm dialog, so it will clear all items from the cart. So we have also a private void handle checkout. So this function is to handle the checkout feature of our system. So we have also if statement for this. For the cart is empty, so it will toss the cart is empty. So it is not allowed to check out if the cart is empty. So in this line of code, we have also a private function for the save transaction to file. So excuse me, we have also try catch for this. So we declare class for file writer with the object writer with a new file writer. So the transaction.txt, so it will save the data for the transaction file. It is saved to the file text file. So we have also a function for the private void preview receipt. So it is allowed to view it is allowed the users to view their receipt. So we have also a private function for the make receipt area. So it will display the receipt of the user. So we have override function for the public void on cart updated. So if the user select product, so it will display in this. We have a for each for this, so it will get the product and display all the subtotal, get tax, and the get total. So here we have J button for the MK button with the name function name MK button. So this we have a main class, so public static void main string arg. So it is the we have a try catch for this, so it will be the starter of our system. So that's all for this video. Thank you for watching.
Greetings everyone. My name is Danilo Cabunas and we will explain the post break. This line define our color palette. We use specific hex code to move away from the default Java look and create a professional dark theme UI. This ensures that colors like header, accent, and sidebar remain consistent throughout the entire application. And for these lines, the build UI method, we use border layout and JSplit pane to divide the screen between the product catalog and the shopping cart. The make header method uses graphics 2D and gradient paint to create a modern sleek top bar with our branding and real-time clock. And for these lines, the make category bar method handles our product filtering. It uses a loop to generate button for each category. When a button is clicked, an action listener triggers the refresh grid functions, allowing the cashier to quickly switch between beverages, snacks, and household items. And for these lines, in the make card method, we create individual panels for each product. We implemented mouse listeners for hover effects and graphics 2D for rounded corners. It also includes logic to visually paint the card using an alpha blended color if the product stocks reaches 0. And for these lines, for the shopping cart, we use JTable with a custom default table model. We overridden the get column class to display product images directly, and we also customize the prepare renderer to implement alternating row colors, which improves readability for the cashier during busy transactions. And that's all.
So, greetings everyone. I'm Anthony Siambat and today I will explain the product class for our finance project in OOP. So, let's start with the package. Pack, package quick mark. So, this is define where the class belong it and it act like a folder or the group in the system. Next, we have the abstract class. So, this is a base class for all products. Next, we have the attribute. So, the product ID, this is a unique identifier for the product. And we have a product name and the price. And we have the category. The category, type of the category like food or electronics. And we have the stock wherein you will see the available quantity. And next we have this image path. This is a location for of the product image or the icon. So next we have the constructor this. So this is to use when creating a new product object, and this is initialized all the attributes. So we have this. So these lines assign the given value to the class field. So we have the getter. So these methods are used to retrieve the values of the attributes. And we have the setter. So this method are used to update or modify the price in the stock. And we have the stock method. So this is to reduce the stock when the product is purchased, and it check first if there's enough stock. And we have this. So this is the method increasing the stock when restock restocking. So we have the abstract method. So this method do not have implementation in this class. So they must be implemented in the subclass. Next we have toString. toString. So this method is used to display the product details in the readable format. So and for the last is this is the format for the product information for the output. So that's all for the product. So the nga greetings. So I will explain the product factory. So we have this. So package. So this is a package wherein define the folder where the class belong. Then we have this import. So these are used to store and manage the multiple product in a list. Next we have this. So the class. So class definition. So this is the class called the product factory. So this is responsible for creating the product object automatically based on a given type. So we have this. So so this is method to create a product depending on its type. So it returns a product object. So we have the switch. So this check the type of product. For example, beverage, snack, and household. So for the case of beverage, so this if the type is beverage, it create a return a beverage object. Then next we have if the type is snack, it create and return a snack object. So next is this. So if the type is a household, it creates and return a household object. Next we have this. So if the type is not recognized, an error is thrown. So next we have this. So this is a method to create and return a list of sample product. Next we have this. So this is to initialize an empty list to store the product. So for this we have so for adding a product, we have add on a beverage product to the list. For example, you add a product with a Coca-Cola, mineral water, C2, Red Bull Energy, Nestle Iced Tea, and Gatorade Sport. So for the snack, um, it adds on like Nova, Skyflakes, Piatus, Cloud9, Hansel, and others. So, and for the household, um, you can add up, you can add like Downy Pub, Downy Fabric, Ariel, Joy, Mr. Clean Floor Wax, Safeguard, Soap Bar, and Colgate toothpaste. And for the return, this is to return the complete list of all the sample products. So that's all for the product factory.
So, dangal greetings to everyone. My name is BJ Bacilonia and I'm gonna explain the cart.java. So, the cart classes serve as the core of the quick mart point of a sales system, managing everything that happens during a customer shopping session. It's built around two well-known design patterns. The singleton pattern ensures that only one cart instance ever exists in the application. The constructor is a private and static get-instance method control access, preventing inconsistencies that would arise from having multiple cards running at the same time. The observer pattern allows other components to register themselves as listener via add observer. And whenever the card content change, notify observer is automatically triggered to keep everything else in system up to date. For item management, the cart maintains a list of cart item, object, and supporting adding, removing, and clearing items. When adding a product, it first checks if the product is already exists in the cart and simply increase its quantity instead of creating a duplicate entry. In both cases, stock is decreased on the product to reflect reserve units. When items are removed on the cart is cleared, those stock units are stored to increase stock, keeping on inventory counts accurate throughout the session. On the pricing side, the cart calculates subtotal by summing all items. Subtotal applies a fixed 12% VAT and add them together for the grand total, all exposed through clean, dedicated methods. Finally, the generate receipt method puts everything together into a neatly formatted text receipt displaying the transaction ID, cashier name, date, and itemized list of purchase and the full pricing breakdown, giving the system a polished and complete checkout experience. Next is the cart item.java. So the cart item class is a simple but essential component of the quick mart system, representing a single product entry inside the shopping cart. It holds the two pieces of information, a reference to the product object and the quantity of the product the customer wants to purchase. The constructor takes both of these in and stores them, while the provided getters and setters allow other part of the system to read or update the quantity as needed. The class also handles its own subtotal calculation through two dedicated methods. Get subtotal computes the standard price by multiplying the product regular price by the quantity, while get discount total does the same but first passes the price through the product applied discount method before multiplying, meaning it automatically reflects any active discount or promotion on that product together. These two methods give the card the flexibility to display both or original and discounted pricing depending on the situation, making the cart item a clean and focused class that does exactly what it needs to without any unnecessary complexity.
So, Donald, greetings. Mine is Mark ABAIRO. Today, I'm going to provide detailed explanation to the quick mart POS system, especially focuses on login module and our custom responsive layout architecture, which is the layout.java. Now, first is the login frame.java. The login frame is the entry of our system. The goal here was to implement a user-centric that balances aesthetic with security. So for this one, um, we utilize the graphics 2D class to override the pane component. This allows to implement the gradient paint for a modern high-end feel rather than a dated gray background. So for the For the security gate, this one. Uh, the attempt login method handles the credential validation. We use the password field to mask the input and swing utilize that invoke later to ensure that when the user logs in, the transition to the POS frame is smooth and doesn't freeze the applications. Now for the layout engine, the rough layout of Java, this one. Um one of the biggest challenges in Java Swing is creating a responsive UI standards. Flow layout is a rigid. If you shrink the windows components on the right, simply disappear. To solve this, we implement the wrap layout, which calculates the available width and real time. So by using the add row method, the layout dynamically grows taller as the windows gets narrower. So this ensures the quick mark interface looks perfect on any screen size, similar how modern website adjusts their content. And that's all. Thank you.